Okay, so our last unit deals with the integral, or last review unit before the end of the school year. We're going to look at reverse power rules, some common integrals, e to the x, natural log x, and the trigonometric integrals, and u substitution, which are really the most common methods for integrating that you're going to run into. So the reverse power rule is literally just the reverse of the power rule for differentiation, which is why we start with this one. But if you have the integral of a power function, then its integral function will look like this. Notice a, our original coefficient, over n plus 1, and then x to the n plus 1, and then plus our constant when we take the integral, because again, we don't know if the derivative got rid of a constant. So we just put the plus c there, unless it's a definite integral, in which case we can find the value, which I'll do some examples of in just a second. If you need the steps broken down, 2 steps. Add 1 to the power of the variable. So here, the power of my variable was n. So you can see in the integral we had n plus 1. I added 1 to that to get the new power, and then I just divide my coefficient by that new power, which is why here we have a over n plus 1. So it is a fairly straightforward method of integration. Remember, the integral tells me the area under a curve or its displacement. So the integral of the velocity takes me to the position function. So we can move up and down that. Acceleration's integral is the velocity. Velocity's integral is position. So that's nice to know. But let's see some examples of this. The reverse power rule. There we go. So we start out with the integral of 6x squared. Very straightforward. It's a power function. I have a variable raised to a power. If I really wanted to, I'll write this out. I could move the 6 out of the integral as a constant and then multiply it back in once I have the integral. But we don't really need to. We have the reverse power rule dealing with constants as coefficients, so we'll just leave it in there for now. But the way I would work this, following my steps, my power in the original function is 2, so I'm going to add 1 to that, so I would have x to the 2 plus 1. And then I would divide 6 by that. So without any simplification, it would look like this, and then plus c. Now clearly, we're not going to leave it like that. In fact, we'd probably skip that step altogether because we all know that 2 plus 1 is 3, and so it would just be x to the third. I want you to notice that I'm starting with the variable first, which is the opposite of what we do with the derivative power rule, where we bring the power down, multiply it to the coefficient, and then move to the variable to subtract 1. So add 1 to the exponent. 2 plus 1 is 3. 6 divided by 3 is 2. And then our plus c for good measure. That's it. Add 1 to the power, divide whatever coefficient we have by that new power, add c, and you've got your reverse power rule. Now, this one was written nicely, and it was a single term. So that's the first exercises you see on Khan Academy with respect to these. But as we move to more complex problem types, oops, let me go over here. This one, where is it? There we go. So here we have the integral of 4x minus 21 fifth root of x squared over 5 minus 8 over x cubed. Again, I can see it's a little small, so I'm going to rewrite it. But this is the integral of 4x minus 21 the fifth root of x squared over 5, and then minus 8 over x to the third dx. I know you guys are all familiar with this. We went over it in class when you guys were still here. But I'm going to work this step by step, showing you how we're going to look at it. So the first thing that I'm going to do is use that property of integrals that allows me to break up an expression like this at the addition or subtraction point. So I'm going to break this up into 3 separate integrals. We get the integral of 4x minus the integral of 21 fifth root of x squared over 5 minus the integral of 8 over x cubed. All of these with their own dx that I forgot to write in. Kind of put that in at the end there, dx, dx, dx. All right. Now, the first integral looks nice. 4x to the first power, it's a power function. We can go ahead and integrate that. But these other 2 integrals are not power functions yet. This one's in radical form. This one's in rational form. They're not set up to use that reverse power rule. So I have to rewrite them in terms of a power function. For this one, there it is. I'm going to use a rational exponent to break this up and rewrite it. And for this one, I'm going to use the property of exponents to bring the x cubed to the top, making it a negative exponent. So we're going to do a little bit of rewriting first to get our integrals into a point where I can just apply that reverse power rule. So here, this one's fine. So it's going to stay the integral of 4x dx. This one, I want to separate out. So I'm going to write the coefficient 21 fifths separate from the variable, which is going to be x to the power over index x to the 2/5 power dx minus the integral, and in this case I'm just going to bring this base up, so it'll be 8x to the negative 3 power dx. So now I've got my integrals split up into 3 separate integrals, and I've written each of the expressions inside the integral as a power function, so now I can just directly apply that reverse power rule. Here, add 1 to the exponent, so that's going to become x squared. 1 plus 1. Divide by that new power. 4 divided by 2 is 2. So we have 2x squared from that first integral. Minus, and then we did the same thing here. Add 1 to the exponent. So 2/5 plus 1, 2/5 plus 5/5 is 7/5. So we have x to the 7/5. And then 21/5 divided by 7/5, and is just keep, change, flip. So we're going to multiply 21/5 by 5 over 7, which is 3. And then we move on to our last integral here, x to the negative 3. We add 1 to the power, negative 3 plus 1, negative 2. Be careful with that. And 8 divided by negative 2 is negative 4. So we end up with that. Plus c. And my last step would be to clean this up algebraically, just to make sure everything was good looking for the algebra. I might want to rewrite this 7/5 power in radical form, especially since that's how it was expressed in the original problem. So we might want to go back to that radical form. I'm okay leaving it as a rational exponent. I actually like these a little bit better. This negative exponent, that's a problem, and the minus a minus there, minus a negative. So really the only thing I would worry about cleaning up is here. Minus a negative is a positive, and then I'd probably write that as 4 over x squared. That rational form is a little easier to do computations with than a negative exponent. I don't really see a benefit in doing computations with a 7/5 power or 5th root of x to the 7th power. So that one is either or. But that's it. We had to rewrite it. So I split up my integral term by term, rewrote my expressions into power functions, and then just applied that reverse power rule on there. And I think that's actually like 3 exercises on Khan Academy. One about the negatives, one about rationals, and then one about rewriting and dealing with that. So there's a lot of reverse power rule on there. You can knock that out pretty quickly. Last, the definite integrals. So when we have boundaries of integration on our integral, so an a and a b, and we actually want to find the value of that integral, will be our last example. So let's go look at that. There it is. So what we've got is the integral from 0 to 5. Those are my boundaries of integration, lower bound to upper bound. And then negative 1/2 x squared plus 2x plus 3 dx. So this is going to work just like the last one. I'm going to break up my integral. Again, we have 3 separate terms. I'm going to rewrite them in terms of power function if necessary, but it's not. These are all already power functions. And then I would apply the reverse power rule, which in this case would get us x to the 3rd, so negative 1/6. X to the 3rd, that's going to be plus x squared, and then plus 3x. Now, that's ignoring the boundaries of integration, but we haven't actually applied those boundaries of integration yet. We need to figure out the value that this function would have under its curve, the area under this curve, from 0 to 5. And luckily we can do that fairly simply. We have a formula. It's f at b minus f at a. And luckily, that's a, that's b, lower bound, upper bound. So it is just plugging in these boundaries of integration and evaluating. So here we would have f at 5 minus f at 0. Plugging those in would be negative 1/6 times 5 to the 3rd power plus 5 squared plus 3 times 5 minus negative 1/6 times 0 to the 3rd plus 0 squared plus 3 times 0. And then just evaluating that. So that is negative 125 over 6 plus 25 plus 15 minus That's 0, 0, and 0. So 0. And then we just, again, evaluate this. Following the order of operations, be careful, write it out, I recommend, just to make sure you're getting all the computations in there, especially with the minus zeros. When we start adding the trigonometry and the other types of functions, the logarithms, the 0 doesn't always come out as 0. So it's always good, even though this is really simple arithmetic, to do the arithmetic. Take your time. Check your answer with a calculator. Negative 125 over 6 plus 25 plus 15 is 115 over 6. Or if we take that as decimal, 19.17. Units. And then we could interpret that in terms of the problem. It could be displacement, the distance a particle has traveled, the work being done. Lots of applications to this in science and such. But that's reverse power rule. I think all we have in this particular unit, reverse power rule, U substitution, and really common integrals and definite integrals. I'm not going to test you on the differential equations. That is on Khan Academy. I recommend looking at it. It's fairly easy. Separate the variables, integrate both sides, solve for y, and you're done. But I will not be assigning anything past the 15th, so Friday will be the last day that I will put any new assignments up. You guys will have one more test posted this week, and that's it. So you got everything you need. The last day for seniors is the 21st. Last day for everybody else is the, I believe, 29th. But I think at this pace, most of you will have everything you need done before then. And I will be posting a few more videos to cover the rest of this. So until next time, we'll see you later.